What does it mean when something arrives from the darkness between stars, carrying with it no history we can trace, no origin we can point to, and no certainty of what it truly is? On a quiet night in 2019, a network of watchful eyes searched the heavens. The Atlas Survey in Hawaii, designed to protect Earth from hidden dangers, swept the skies for faint movements against the eternal stillness. Its twin telescopes captured a glimmer that did not belong, a wandering fragment racing along a path too strange, too fast, too unfamiliar to be one of our own. At first it seemed like another comet, fragile and distant, a traveler bound by the same rules as countless icy wanderers before it. But its trajectory told a different story. It was not orbiting the sun. It was not a child of this solar system. The path cut across the planets at impossible speed, a line that reached back beyond Neptune, beyond the Kuiper Belt. Beyond even the gravitational embrace of our star, astronomers named it 3I Atlas, the third confirmed interstellar object after the mysterious Oumuamua and the comet Borisov. Its arrival was not expected. Its presence was not ordinary. At Harvard, whispers stirred among astrophysicists who had not forgotten Oumuamua's strange acceleration and the unsettling questions it left behind. Avi Loeb, who had once dared to suggest it might not be natural, turned his gaze quickly toward this new messenger. If the first visitor had left a riddle unsolved, the second had deepened the mystery. Now a third had come, and with it a question, both thrilling and terrifying. What kind of universe sends us such fleeting, unexplainable guests? For centuries, astronomers believed the solar system was a sealed arena, a cosmic stage where the sun and its planets played out their quiet orbits. Comets and asteroids, icy wanderers and rocky remnants, were thought to belong exclusively to this one star. What lay between the stars was imagined as a near-perfect emptiness, a gulf so vast and unforgiving that any small fragment of matter cast adrift within it would be ground down, frozen solid or eroded into dust long before it could ever cross. The abyss then came Oumuamua in 2017, and Borisov in 2019. Both were catalogued as interstellar, but they left questions gnawing at the edges of science. Now, 3I Atlas appeared, the third of its kind, and once again, astronomy was confronted with something it was not prepared to explain. The shock came not merely from its trajectory, though that alone was extraordinary. The object cut across the solar system at more than 40 kilometers per second, far too swift to have ever been bound to the sun. Its path was a hyperbola, not a closed loop, a mathematical fingerprint that revealed its alien origin. Yet, the greater astonishment was what happened next. Unlike Oumuamua, which defied explanation with its strange acceleration, and unlike Borisov, which behaved more like a classic comet, 3-1, Atlas began to fall apart. Its nucleus disintegrated into fragments, scattering into faint debris, its brightness fluctuating wildly. A body that had traveled for millions, perhaps billions of years between the stars, seemed to crumble within months of entering the warmth of our system. This was not what theory had predicted. Interstellar objects, hardened by eons of exposure to cosmic rays and frozen in the vacuum, were expected to be among the most durable relics in the universe. To endure interstellar flight was to survive forces beyond comprehension, the constant bombardment of high-energy particles, the gravitational slingshots of stars, and the slow erosion of time itself. A body that fragile should never have made it here. Scientists struggled to reconcile the contradiction. If 3I Atlas was so delicate, what held it together on its journey through the galactic void? If it was truly unstable, why had the rigors of interstellar space not destroyed it long before Earth's telescopes could glimpse it? The paradox deepened when astronomers compared its light curve to known comets. Its breakup released energy and reflection patterns unlike typical solar system bodies. Was it made of exotic ices, substances that vaporized the moment they tasted sunlight? Hydrogen icebergs, nitrogen fragments, even materials unknown to terrestrial laboratories were proposed. Each theory carried weight, yet each collapsed under its own impossibility. Hydrogen ice would have evaporated long before reaching the solar system. Nitrogen fragments required parent worlds so vast and improbable they strained credibility. The deeper the investigation, the greater the unease. If this was not a stable rock or a common comet, then what was it? Here lay the heart of the scientific shock, a messenger from beyond the sun that seemed to break the very rules of survival. Something fragile enough to shatter at its first encounter with our star, yet resilient enough to cross light years of interstellar wilderness. Its presence was a contradiction. Its destruction was a riddle, at Harvard and in observatories across. The world astronomers asked the same haunting question. What kind of material could not endure the briefest warmth of a star, and yet somehow endure the endless, merciless voyage between them? The cosmos had delivered a puzzle that threatened the very logic of astronomy, and with it came a quiet fear, one born not from superstition, but from the realization that perhaps we do not yet understand what waits in the darkness between the stars. Asterisk. When 3IATLAS announced its arrival, the first step for astronomers was simple yet profound: measure its light. In the silence of space, brightness becomes a language, a code written in the rise and fall of reflected sunlight. Telescopes across, the globe began to trace its light curve, those delicate oscillations that reveal shape, spin, and structure. But almost immediately, the readings refused to conform to expectation. Instead of a steady rhythm, its brightness flickered unpredictably, suggesting a body not whole and solid but unstable, fragmented, raveling before the eyes of science. Trajectory plotting soon confirmed what the initial discovery had implied. The path was undeniably interstellar, hyperbolic and open-ended, a trajectory that betrayed its alien origin. It had come from the void beyond our star, and once its brief passage was complete, it would return to that abyss, never to be seen again. This certainty of its foreignness sharpened the urgency. Every hour mattered, every observation a final chance to capture what might never come again. Spectroscopy, the tool that dissects light into its elemental fingerprints, was turned toward the faint glow of a talus. Yet here, too, the data whispered in riddles. The object was faint, fast, and distant, its spectral lines blurred by motion, its chemical voice smothered by weakness. Still, fragments of evidence slipped through, traces that hinted at volatile ices, but in proportions unlike those of familiar comets. Some signatures suggested carbon-rich compounds. Others hinted at exotic ices, substances that should not have endured the ages of interstellar exile. The clarity was never enough to form consensus, but it was sufficient to deepen the strangeness. Then came the anomalies. As the object approached the inner solar system, it broke apart more rapidly than models predicted. The nucleus fractured, scattering fragments like brittle glass, a behavior closer to a doomed, unstable comet than a hardened traveler from deep space. Yet the speed and violence of the disintegration raised unsettling questions. Was this body, composed of material too fragile to survive the gentlest warming? Was it made of chemical compounds unknown in local comets, born of alien stellar nurseries where conditions differ wildly from our own? Its light curve revealed sudden bursts of brightness, flashes of reflection inconsistent with smooth sublimation of surface ice. Some suggested explosive venting of volatile gases. Others considered more exotic explanations, including phase changes of unfamiliar ices or structural collapse of a fragile porous framework. A handful of theorists speculated about crystalline hydrogen or nitrogen, substances so delicate that even distant starlight might destabilize them. Yet such matter should never have lasted through the cosmic voyage across light years. Each dataset added layers to the puzzle. Its comparison with Oumuamua and Borisov only emphasized the enigma. Oumuamua had shown acceleration without visible outgassing. Borisov had behaved like a classical comet, stable, consistent, and familiar. Atlas, by contrast, seemed to be dissolving before it could be fully studied, erasing its own evidence in real time. 3 objects, 3 visitors from interstellar space. None of them fit comfortably within established categories. Astronomers gathered in quiet. Conferences and wrote papers filled with cautious language, but behind the scientific restraint lay a sense of awe and unease. Was Atlas a fragile shard from the breakup of a distant exoplanet? A fragment hurled into the dark by some violent cosmic collision? Was it a body formed in a stellar nursery under alien chemistry, built of compounds untested in our solar system? Or was it something even more difficult to accept, a category of objects so unfamiliar that science lacked the words to define it? The deeper the investigation went, the more the answers dissolved. Instruments sharpened the mystery, but did not resolve it. Every anomaly seemed to resist closure. What was Atlas, icy, metallic, or something stranger still? Its fragments drifted into darkness, carrying their secrets with them. Humanity had caught a glimpse, recorded the faint signatures, then watched as the evidence slipped away, leaving behind not clarity, but an expanding horizon of questions. For scientists at Harvard, and for astronomers around the world, 3I Atlas became not just an interstellar visitor, but a mirror reflecting the limits of human understanding. The universe had offered a clue, but in a language so unfamiliar it bordered on the incomprehensible. And so, the deeper the data went, the deeper the mystery became. As if the cosmos itself were reminding humanity that some truths arrive only as questions, fragile and fleeting, vanishing before certainty can ever take hold. At first, astronomers thought they had seen this story before. Fragile comet enters the solar system, warms under the sun's gaze, vents gases, fractures, and drifts apart. It is a script written countless times in the long history of commentary. Observations. But as the days passed and 3IATLAs revealed more of itself, the familiar pattern began to unravel. Its disintegration did not follow the expected sequence. Its fragments did not drift as models predicted. Its very destruction was wrong. Comets in our solar system are known to fracture, but usually the timing is precise. The sun's heat penetrates their icy crusts gradually, forcing jets of vapor to escape in spurts, until sometimes the core cannot withstand the pressure. With Atlas, the breakup came far too soon. Long before reaching the regions where ordinary comets succumb to solar energy, its nucleus cracked apart, scattering fragments into a loose cloud that confused every attempt at prediction. Astronomers measured the pieces, their path skewed and unpredictable. Instead of a neat dispersion governed by thermal stress, they spread chaotically, their brightness fluctuating in irregular pulses. Some pieces seemed to vanish altogether, evaporating into invisibility. Others lingered with unexpected persistence, glowing faintly long after theory suggested they should have faded. The behavior did not resemble the tidy mechanics of sublimating ice. It resembled something far less stable, far less understood, and the timing of this collapse carried its own implication. For an interstellar object to travel for millions, perhaps billions of years, through the cold and hostile void, must have been sturdy, hardened, resilient against the endless bombardment of cosmic rays and gravitational encounters. How could such an ancient wanderer dissolve so easily when exposed to the gentlest heat of a star? How could it survive the merciless emptiness between suns, yet disintegrate within months of entering our reach? The paradox deepened, a contradiction that made even seasoned scientists uneasy. This was not the first time interstellar visitors had defied understanding. Oumuamua, the first known traveler from beyond, had raced through in 2017 with no clear explanation for its behavior. Shaped like a shard or perhaps a pancake, it showed no visible signs of outgassing. It accelerated as though pushed by some invisible hand. Radiation pressure, exotic ices, even the speculative notion of a thin, artificial sail were proposed, each theory more unsettling than the last. Then came Borisov in 2019, a comet that behaved more like the familiar. It vented gases, shed dust, and fit the expectations of astronomers. For a moment, relief had settled in. Perhaps Oumuamua was only an anomaly, a rare outlier, not a challenge to the framework of planetary science. But Atlas destroyed that hope. Its premature disintegration and erratic fragmentation placed it alongside Oumuamua in a growing category of the unexplained. 3 interstellar objects, 3 distinct stories. One moved without outgassing. One behaved like a comet. One collapsed too quickly, its material behaving in ways no model could capture. The pattern was not one of confirmation, but of contradiction. Instead of establishing rules, each new visitor dismantled them. In the quiet halls of observatories, in the crowded rooms of academic conferences, this realization spread with a mixture of awe and dread. The universe was not giving answers, was delivering riddles, each more confounding than the last. If interstellar objects could not be trusted to behave within the bounds of physics as understood, then what did that say about the environments that produced them? Were these fragments born in stellar nurseries utterly alien to our own, built of chemistries unimagined? Or were they shaped by processes yet undiscovered, forces that hint at gaps in our deepest theories? Astronomers spoke carefully their papers, filled with cautious language, but the undercurrent was clear. These objects were not just scientific curiosities. They were cracks in the mirror of certainty. If each visitor arrived bearing contradictions, then perhaps the story of matter itself, its durability, its composition, its response to stars, was not as universal as once believed. Atlas lingered only briefly before fading into invisibility, its fragments dispersing into the background haze of the solar system. Yet the questions it left behind did not fade. It grew sharper, heavier, pressing on the boundaries of science. The dread was not theatrical, not the fear of catastrophe. It was the quieter, more unsettling fear that the universe was stranger than the models designed to contain it, with each interstellar messenger. The cosmos was not confirming the rules of astronomy, it was breaking them. And in that realization lay a truth both humbling and profound. The story of interstellar visitors had only just begun, and humanity was still unprepared to understand what they truly were. In the long history of astronomy, every mystery eventually bends beneath the weight of theory. When an object refuses to behave as expected, when its trajectory and brightness and very survival contradict the textbooks, the response is both instinctive and profound. Hypotheses bloom. Models multiply. Imagination stretches toward the edges of the possible. With 3IATLAS, as with Oumuamua before it, science began to weave explanations. Yet with each attempt to settle the riddle, new layers of uncertainty emerged. The first and most conservative proposal was that ATLAS was simply what it appeared to be, a comet from another star system, a fragile wanderer built of ice and dust, expelled from the gravitational nursery of an alien world. In this view, its disintegration was not mysterious, but inevitable. Perhaps it had been fractured long ago, weakened by cosmic collisions, so that its encounter with the sun merely completed its ruin. Its erratic brightness might be explained by jets of vapor streaming unpredictably from an already unstable surface. But the theory faltered when weighed against the sheer improbability of such fragility. A body this delicate should not have survived. A voyage across interstellar space. For millions of years, it would have endured the piercing radiation of cosmic rays, the shattering violence of tidal encounters with stars, the grinding friction of interstellar dust. To arrive intact, only to fall apart at the first touch of the sun's warmth, defied ordinary logic. If Atlas was merely a comet, it was a comet unlike any seen before. Another hypothesis suggested that Atlas was a fragment, a shard torn from the surface of a distant exoplanet. In planetary systems far from our own, cataclysms are common. Planets collide, moons shatter, stars themselves swell and contract, sending waves of destruction through their surroundings. From such events, fragments of rock and ice may be hurled into interstellar exile, wandering for eons before finding another star. Could Atlas have been one such relic, the icy remnant of a world destroyed? If so, its weakness made sense. It was not forged in isolation like a comet, but broken from a larger body, fractured from birth. Yet this theory too encountered problems. The chemical signatures hinted at substances rare even in our system. The timing of its breakup did not match the expectations for planetary fragments hardened by billions of years of travel. The details resisted neat classification, and the mystery remained. Others suggested a looser structure entirely, not a solid body but a cluster, a fragile assembly of cosmic dust bound weakly by gravity or cohesion. Such an aggregate could easily disintegrate under solar heating, explaining ATLAS's sudden collapse. But again, the paradox surfaced. A dust cluster this fragile should not endure light years of exposure to the interstellar medium. Would have been stripped apart long before it reached our telescopes. The idea provided partial clarity, but collapsed under its own contradictions. As the natural models struggled, more exotic ideas were summoned. Some physicists speculated that Atlas might have been composed of exotic ices unknown in the solar system. Hydrogen icebergs were proposed. Vast shards of molecular hydrogen formed in the dense molecular clouds where stars are born. Such an object could explain both fragility and volatility, evaporating almost instantly upon approach to sunlight. Others suggested nitrogen icebergs, fragments from the frozen crusts of distant exoplanets similar to Pluto. These possibilities carried a haunting allure, evidence of chemistries alien to Earth, revealing the hidden diversity of planetary systems. But hydrogen icebergs raise severe doubts. Hydrogen is the most common element in the universe, yet solid hydrogen is notoriously unstable. Models suggested such bodies could not survive more than a few million years in interstellar space before sublimating away. If Atlas had truly been hydrogen, how could it have reached us after a voyage measured not in millions but in billions of years? Nitrogen, too, strained credibility. The sheer number of nitrogen fragments required to explain even a single detection suggested planetary processes on an unthinkable scale, stripping worlds bare in quantities beyond measure. And then, as always at the edge of knowledge, came the most controversial speculation. Avi Loeb, professor at Harvard, had already ignited debate with his claim that Oumuamua might have been artificial, a relic of alien technology. Perhaps a probe or a fragment of a light sail. With Atlas, he raised the possibility once again. Could interstellar visitors be more than random debris? Could they be signals of intelligence, relics of civilizations beyond our own? The idea was not embraced widely, but it could not be dismissed outright. For decades, humanity has wondered how alien technology might travel the stars. Probes sent across light years would be small, fast, and built to endure the void. Some might fragment, some might decay, leaving only traces of their origin. Atlas, breaking apart in unexpected ways, seemed at times to echo those speculative visions. Still, extraordinary claims demand extraordinary evidence, and evidence was lacking. No clear signatures of artificial design were found. No repeating signals, no metallic spectra, no unmistakable hallmarks of construction. The alien hypothesis remained provocative, but unproven. Yet even as the artificial possibility receded into speculation, its shadow lingered. For what disturbed scientists most was not the plausibility of alien technology, but the deeper truth revealed by these interstellar messengers. If each visitor defied explanation, one accelerating without outgassing, another collapsing too. Soon, another behaving half-commit, half-stranger, then the universe was telling us something profound. Our models of planetary formation, of interstellar chemistry, of cosmic survival may be incomplete. The very materials that make up other worlds may be different in ways we cannot yet imagine. Theories abounded, but certainty remained elusive. Fragile comet, planetary shard, dust cluster, exotic ice, alien relic. Each offered part of the picture, none offered completion. Atlas was gone, dissolved into invisibility, leaving only fragments of data and a trail of unanswered questions. And in those unanswered questions lay the most haunting possibility of all, that humanity is standing at the edge of a truth too vast, too complex, too alien to yet be grasped. The cosmos had given a messenger. Science had given its interpretations. But in the end, Atlas remained what it had always been, a mystery. Shimmering for a brief moment under the gaze of one star, then vanishing back into the dark, leaving behind not answers, but an invitation to wonder. Asterisk. In the vast theater of the cosmos, human eyes remain limited. The universe stretches beyond imagination, yet the instruments designed to study it are bound by technology, by atmosphere, by time itself. When 3i Atlas passed through the solar system, The challenge was not only its mystery, but the fleeting nature of its visit. These interstellar wanderers arrive without warning, racing past at tens of kilometers per second. Their arcs brief, their opportunities fragile. The current generation of telescopes, even at their most vigilant, strain to capture more than fragments of their story. Most of what was known of Atlas came not from high-resolution imagery, but from faint smudges of light. Photons scattered across. Detectors, their messages buried in noise. The speed of such objects meant they spent only weeks, sometimes days, within range of meaningful observation. By the time trajectories are calculated and global instruments turn toward them, they are already fading into invisibility. The universe reveals its secrets in passing. While human technology struggles to keep pace, this limitation has forced astronomers to imagine what comes next. On the slopes of Cerro Pachón in Chile, the Vera C. Rubin Observatory nears completion. Its legacy survey of space and time, the LSST, promises to map the entire southern sky every few nights with unprecedented depth. Unlike earlier surveys, Rubin's gaze will not miss fleeting streaks of light. It will record them systematically, building a library of motion, a memory of every transient visitor. Interstellar objects, this means detection earlier, tracking sharper, and opportunities to study them longer before they vanish again into darkness above Earth. The James Webb Space Telescope offers another dimension. Though not designed for fast-moving intruders, its infrared eyes are capable of probing compositions that ground-based instruments cannot. The faint thermal glow of exotic ices, the subtle fingerprints of carbon chains, the whispers of chemistry born in alien stellar nurseries, all lie within its reach. Yet Webb's time is precious, its schedule crowded with galaxies and exoplanets. To study interstellar wanderers requires coordination, rapid calculation, and the will to interrupt other cosmic priorities for a messenger that may never return, beyond telescopes. Scientists turn to machines that simulate the impossible. Supercomputers run models of fragmentation, testing what materials might survive the long exile between stars, only to collapse within weeks of encountering the sun. They simulate hydrogen icebergs dissolving under starlight, nitrogen shards stripped from the crusts of frozen exoplanets, and carbon lattice crumbling in unexpected ways. Each model narrows possibilities, but does not erase doubt. The data remains too thin, the events too rare, the anomalies too many. Some proposals reach further. Still, concepts for interstellar probes are taking shape, designed not to wait passively for the next messenger, but to pursue it, powered by solar sails or nuclear propulsion. Such missions would attempt to intercept a visitor while it still lingers near the solar system, to fly alongside it, to measure its gases, its dust, its structure directly. This would be the ultimate experiment, turning speculation into certainty. Yet such missions remain dreams on paper, awaiting political will, technological maturity, and funding on a scale few are ready to provide. Meanwhile, institutions prepare as best they can. At the Harvard-Smithsonian Center for Astrophysics, researchers refine strategies to catch the next object in sharper detail. Networks of observatories coordinate, ready to respond within hours of discovery. Algorithms trained to recognize unusual trajectories now scan survey data, searching for the hyperbolic signatures of another interstellar intruder. The lesson of Atlas, as with Oumuamua and Borisov before it, is clear. The universe will not wait for human readiness. The next messenger may already be on its way. And so astronomy exists in a state of vigilance. Telescopes sweep the sky. Computers model the unthinkable. Scientists prepare for visitors they cannot predict. Each fragment of data becomes precious, each photon an artifact of an alien journey. Humanity builds instruments not only to see deeper, but to listen faster, to catch whispers from the dark before they fade forever. The pursuit of interstellar objects is more than science. It is a recognition of fragility. These wanderers pass without warning, leaving riddles that mock certainty. To meet them with sharper eyes, to intercept them with machines, is to accept that knowledge must be seized quickly before it drifts away into the void. The tools of today may be limited, but the promise of tomorrow is clear. The next time a stranger comes from the stars, humanity will be waiting. And perhaps in that fleeting encounter, the cosmos will finally give more than a question. It may give an answer. In the silent corridors of the universe, humanity waits. It waits not with weapons or fortifications, but with telescopes pointed into the dark, hoping to glimpse a fragment of what lies beyond its fragile corner of the stars. Each interstellar object that passes is more than a stone or a shard of ice. It is a messenger from another time and another place, a piece of a story written in a language still undeciphered. 31ATLAS was one such letter. Its arrival carried the weight of distance measured not in millions of kilometers, but in light years. It bore the scars of a voyage across stellar deserts, through the magnetic storms of galaxies, through the relentless tide of radiation that erodes and reshapes everything it touches. And yet, when it came close enough to be seen, it shattered. Its fragments scattered like words torn from a page, leaving sentences incomplete and meanings unfinished. Humanity looked on, attempting to translate. The brightness curves, the broken trajectory, the fading spectrum, all became parts of an alphabet that did not fit into the familiar grammar of comets and asteroids. Some wondered if these visitors are cosmic texts, fragments of knowledge, cast adrift. Some may be torn before they reach us. Some may be misunderstood entirely. And some may carry truths too vast for minds, evolved on a single small planet to comprehend. The fear raised by Harvard's astronomers was not the fear of monsters. It was the fear of ignorance. If these visitors are not natural in the ways we expect, then they reveal how little is truly known about the cosmos. They remind us that our science, powerful though it is still young. To misinterpret them is to misread a language that may contain revelations about the origins of worlds, the chemistry of distant stars, perhaps even the possibility of intelligence older than our own. Atlas has long since vanished. Its dust is dispersed, its nucleus dissolved, its fragments scattered into invisibility. But absence leaves a presence of its own. It left behind a scar of questions etched into the scientific imagination. Reminder that the universe is not tame. The night sky does not merely reflect beauty, but also carries danger, uncertainty, and the unknown. There is awe in this realization, not despair. To know that the cosmos can still surprise us is to know that discovery is far from complete. These fleeting visitors, these interstellar messengers, awaken something deeper than fear. They awaken wonder. They remind a species that clings to one world that it is part of a greater story written across stars and centuries. The questions left behind by 3IATLAS are not ends, but beginnings. They are the sparks of future telescopes, future missions, future generations of minds willing to confront the unknown. The Harvard scientists did not fear ghosts or legends. Their fear was more profound. It was the recognition that in the brief passages of such objects, humanity is staring into truths it cannot yet contain. The cosmos does not yield easily. It offers riddles in the form of visitors like Atlas, glimpsed for a moment, gone forever. And in that fleeting contact lies the most humbling lesson of all. Humanity has only just begun to glimpse the true strangeness of the universe. The rest waits in silence, patient, immense, and unknowable, until the next messenger arrives.